Higher order derivatives. You may be wondering, can you find the derivative of a derivative? Well, the answer is yes, you can. Finding the derivative of a derivative is called the second derivative. Furthermore, taking the derivative of that would be called the third derivative, and so on. A derivative, or now what we will refer to it as the first derivative, represents the slope of a curve. Higher order derivatives also represent various aspects of a function's graph. We will be discussing these applications in the next unit. For now, we will work on finding and simplifying them. The notation for higher order derivatives is shown here below. We usually write the second derivative with 2' or 2 apostrophes, and it's read as f double prime of x. This one with y would be read as y double prime. You could also see something in this format, and it is read as the second derivative of y with respect to x. For the third derivative, it really closely resembles the second derivative, and it's read as f triple prime of x, or y triple prime, or this notation where the 3 is in superscript between the d and y over dx, and then 3 again in superscript. It's read as the third derivative of y with respect to x. Once you get to the fourth derivative and beyond, you're told which derivative you're looking for by a number that's appearing in parentheses in superscript. So in this part, for this notation, we're finding the fourth derivative of f of x, or the fourth derivative of y. And this one is asking for the fourth derivative of y with respect to x. Same with the nth derivative, we're finding the nth derivative of f of x, the nth derivative of y, or the nth derivative of y with respect to x. And it's important to note that the exponents in this notation do not mean the derivative squared or the derivative cubed, etc. They are just used to tell you which derivative you are finding. Find f double prime of x if f of x is equal to 2x to the fourth minus 3x cubed plus 5x plus 1. And we can use the power and sum and difference rules to find the derivative of f of x, or f prime of x. And it is equal to 2 times 4, which is 8, and then x raised to the third power, it's 1 less than 4, minus 3 times 3 is 9, x to the second, because 2 is 1 less than 3, and then this exponent with 5x is to the first, so 1 times 5 is 5, and then we would be left with x to the 0, which any variable to the 0 power is 1, and then the derivative of the constant 1 is 0. And once we have the first derivative, we can use it to find the second derivative by taking the derivative of the first derivative. And again, we're using the power and sum difference rules. So 3 times 8 is 24, x raised to the second power, it's 1 less than 3, minus 2 times 9 is 18, x to the first power, or x. Find the third derivative of y with respect to x, given that the function is y equals negative 2x to the third minus 1 divided by x to the third. Start by rewriting our function y so that we have integer exponents. In other words, get rid of this 1 divided by x to the third. It's equal to x to the negative third power. So we have y equals negative 2x to the third minus x raised to the negative third. Now we can take the derivative. And we are going to use the power and sum and difference rules. So the derivative of y with respect to x is going to be 3 times negative 2, or negative 6, x raised to the 3 minus 1, or second power. And then we have negative 1 times negative 3 is positive 3. And we have x raised to the negative 3 minus 1, or negative fourth power. So this is our first derivative. Now we can find the second derivative of y with respect to x. So again, we're going to use the power rule and the sum or difference rule. So we have 2 times negative 6 is negative 12, and then x to the second minus 1 means x to the first, and then negative 4 times positive 3 is negative 12, x raised to the negative 5 power, because negative 4 minus 1 is negative 5. And our goal here is to get to the third derivative, so we're going to have to take the derivative of this one too. Let's see how that goes. So in finding the third derivative, we're going to apply the power and sum difference rules one last time. So we have negative 12x to the first here. If we multiply 1 times negative 12, we still have negative 12. And then we'll have x to the 0, which is just 1, so we don't have to rewrite it. Plus 60, we got that by doing negative 5 times negative 12, positive 60, and then x raised to the negative 6th power. We can rewrite our second term and move the negative exponent into the denominator, and that's written as negative 12 plus 60 divided by x to the 6th. This brings up an interesting question. How many derivatives must you take, depending on the power of x, until the derivative reaches 0? Take a moment to pause this video and think about it, and when you're done, unpause it. Well, when you're given a polynomial of degree n, you must take the n plus 1 derivative to reach 0. So for example, if we started with f of x is equal to x cubed, the degree is 3. And if we continue to take the derivative, the first derivative would be 3x squared, second derivative would be 6x to the first power, or 6x. Third derivative would be 6x to the 0, or just 6. And then the derivative of 6, or any constant, would be 0. So it would take us, the fourth derivative would be needed in order for us to reach 0. So again, in this example, the degree is 3, so the fourth derivative should equal 0. If your degree was 5, then your sixth derivative would be 0, and so on.